Okay, here we go. This is assignment 7F. And again, we are revolving things, creating volumes around uh, different rotations. And I believe that we're going to be moving these axes around, but also they lighten up the constraints by allowing us to use whatever method that we want. So whether that be the shell method or the disk method, whatever we want, it's all good in the hood. All right, so it's kind of in your best interest to kind of understand what the heck a picture and the bounded region looks like in this situation. So we have the square root of x that is provided right here. We have a y is equal to 0, which is that guy. And then we also have an x is equal to 3, which is this right here. So if this is the region that is bounded, I think an integration of this style is probably in your best interest. Okay, probably in your best interest to integrate that way. So that is set it up as a dx method. As a dx method is kind of the way that you probably want to go. So again, this starts at 0 and goes to 3. And then we can change it up if we absolutely need to. But this is kind of the method that is probably most convenient. All right. So here we go. We are going around the x-axis. So that's built for the dx. So that is a method that we're going to do the pi r squared method. So this volume is going to be pi, the integral from 0 to 3 of the radius, which is that square root of x squared dx. So pi r squared method. And so this is going to be just a straight up x. So we have 1/2 x squared. I'll shrink this down here in just one moment. And so this is what? 9 minus 0. So this is 9 over 2 pi. Okay, here we are going around the y-axis, so this is not a dx method. So this is probably the shell method that you'd probably want to use in this situation, the shell method. So this is going to be the volume is equal to 2 pi, 0 to 3 of x, and the square root of x dx. All right, so x and the equation. All right, so this is going to be 2 pi 0 to 3 of x. This is 1 plus 1/2, so this is 3 over 2. So this is x to the 2/3, excuse me, I'm sorry, x to the 5/2, or the 2/5, and 0 to 3. So let's see how this works out. Okay, this is 9 square root 3, 9 square root 3 minus 0. Okay, and now here's kind of why they are bringing this up, and topic we kind of talked about a little bit before, but we are absolutely going to know how to do this by the end of today, and that is what happens when we move these axes around. Like, like maybe it's not the x-axis anymore, or maybe it's not the y-axis anymore, but maybe it might be something else. And so let's go ahead and take a look at these these methods right here. Okay, here in letter C, they're moving the axes, color here, axes till x is equal to 3. So x is equal to 3 is now going to be the axis of rotation. Okay, so that's not that big of a deal, but notice how it's still a vertical rotation. And so because it's a vertical rotation, we probably need to adjust our equation just a teensy-weensy bit. And I'll show you how. So we're still going to do the shell method because it's a vertical rotation, but we're still going to do it in a dx. All right, so here is how we are going to set up this guy. So we pretty much do everything the exact same way that we have done. So the volume of this guy is going to be 2 pi integral from 0 to 3, and it's going to be x, and it's going to be, what was the equation of this? Square root of x? Square root of x dx. Okay, so we're going to pretty much do it the exact same way. However, how to move the axes? The axis was at 0, but now is at 3. So what you do is, whatever the big is, you want this to remain positive. All right? And so if x is a number that is going to jaunt from 0 all the way up to 3, you need to make 3 minus that. 3 minus that. So that number remains positive. If x is in the motion from 0 to 3, that is going to remain positive. And so, in essence, what typically happens when you manipulate an axis is you put the new axis right there, and it'll be minus your x. Typically, not all the time, because if it's over here, then it's going to be manipulated to something a little bit different. But just note that there might be some strange things happening from time to time, but this is what's going to happen. Okay, so this is our new setup now. We've moved our axes of rotation. We're good to go. This should get us what we want to get. So thinking of this as an x to the 1/2, this is going to be 3x to the 1/2 minus x to the 3 over 2. All right, so here we go. X to the 3 over 2, 2/3 would be just a 2, minus x to the 5 over 2, so this is a 2/5 in the world of 0 to 3 with 2 pi. Okay. Okay, so here we go. 3. Okay, so this is 12 root 3 over 5, 2 pi. So this is what, 24 root 3 over 5. Okay. Next problem. Similar. picture? Similar, we are still going to integrate from 0 to 3, but now the axis is over here at 6, and so we have to adjust accordingly in that situation. So again, it's most advantageous to us to integrate up and down in dx style. So what we're going to do is we're going to stay with this shell method in this case, because we're not revolving around the x-axis or anything horizontal. So we're going to remain in this method, and the new axis is at 6. And so when x goes from 0 to 3, again, this number is going to be a positive no matter what. And again, this is the square root of x, that's the equation itself, dx. Okay, so this is 6x to the 1/2 minus x to the 3 over 2. And it's just math, math, math from here on out. Just gotta make sure I did that. Yeah, that's 6. Okay, so we're kind of manipulating the axes of rotation here using the shell method. Let's hope they kind of change that up, and let's show how to really kind of hammer this home using the disk method. Let's kind of hope they bring up some of these questions. Okay, so here we go. Oh, I think we saw this in the last. Yeah, so sorry, I have all these internal thoughts going on. So we have this square root of x, and we have this upside down parabola, which I kind of did it like this. Now, just because of the way that the equations are written, again, it's probably advantageous for us to integrate up and down style. Otherwise, you're going to have to manipulate this so this is an x is equal to somehow. Like, and again, I'm not exactly sure how you do that. So I like the equation written as this. So if I'm going to be integrating, this has to be something of the dx style. So dx is kind of the way that I kind of want to integrate this one, just because that's the way that the equations are initially set up. So dx is kind of the method that I want to integrate that. Now, again, we'll see how these things are going to be rotated, and we'll take that into consideration. All right, so if I'm rotating this about the x-axis, okay, the x-axis, that is a dx, that is the disk method, and that's set up for that. And so the top is the blue, the bottom is the red, and so make sure I have the big radius minus the little radius, each individually squared. All right, so here we go. The volume of this situation is going to be pi integral from, this is from 0 to 2. This is from 0 to 2. Of the blue, which is the 4x minus x squared. So that's the big radius minus the little radius squared dx. All right, doing a little bit of math here. This is what? positive x to the fourth minus 8x to the third plus 16x squared minus x to the fourth with the second bit. So x to the fourth drop, and that's what the equation is going to be. Negative 8x to the third plus 16x squared. Okay. Okay, now in this next problem, this axis of rotation is now a vertical at y is equal to 6. Excuse me, it's still a horizontal. It's still a horizontal, and it's moved to y is equal to 6. So it's moved way up here. Okay, it's moved way up here where y is equal to 6. All right, so how do we move the axes as far as the disk method is concerned? And now, if you see it on a multiple choice question, it's going to look a little bit different than the way that I do it, but I kind of like my method. Jeepers creepers, it's not allowing me to move that. Okay, it's going to look a little bit different, but it's, I don't know, it's the way that I do it. So, and I'll show you how it'll look different in multiple choices, things like that. Okay. So here, notice how the big radius and the little radius is now different from the axes of rotation. From the axes of rotation now, the big radius is now technically the red line, and the little radius is now technically the blue line. So it's the same idea, but we have with the but the big radius and the little radius are now manipulated a little bit. Okay. And here's how you manipulate it. So we set it up same way. It's a horizontal, so this is a disk method. So this volume is going to be equal to pi, and then it's going to be big radius squared minus little radius squared. So this is still 0 to 2. And now the big radius is the red, which is the positive x squared. And so here's how I do it, and this is where it differs a little bit, is I put on that new axis as a subtraction. So I subtract off the new axis. Okay, I subtract off the new axis. Now, how almost all the multiple choice show it is usually the other way around. Yeah, the other way around. But not to get too mathematical about this, not to get too mathematical, but it doesn't matter. Okay, instead of manipulating, like bringing in a negative to this huge long potential polynomial, all I'm going to do is I'm going to subtract off on the back side, and it doesn't really matter, because long story short, this is a difference. Now, whether this is a positive or a negative, it doesn't matter, because ultimately you are squaring that number no matter what. So whether you have a positive difference or a negative difference, when all said and done, that is going to come out to be the difference squared. No matter how you turn it, it's always going to be positive when all said and done. All right, so for simplicity's sake, I just subtract off on the backside. Okay, I just subtract off on the backside, and the squaring of the axes will take care of it itself. All right, so that's the big radius, and now the little radius is going to be 4 minus x squared. Okay, and then, 4 minus x squared, and then subtract off the new rotation. Sorry, 4x minus x squared. Sorry, 4x minus x squared. Okay, now this is going to be, I don't know, kind of a lot of math that I don't actually show a lot of times. But let's just go ahead and, just for giggles, let's take a look at this. What happens when this gets squared? All right, so let's begin with this first negative x squared. So that'll be a positive x to the fourth, negative 4x to the third, positive 6x squared. Now that front negative x squared is taken care of. The middle 4x, that'll be a negative 4x to the third. That will be a positive 16x squared, and that'll be a negative 24x. Okay, the back negative 6. That is going to be a positive 6x squared. That is going to be a negative 24x, and that is going to be a positive 36. So this will come out to be x to the fourth, negative 8x to the third, plus 28, excuse me, plus 28x squared, and negative 48x plus 36. Okay, that is that. I'm pretty sure I'm right with that portion of the problem. Okay, I'm going to save that right there. I'm going to square this second piece, which is x to the fourth minus 12x squared plus 36. Now, note that this long polynomial is technically negative. So it's going to be negative all this stuff. And so what this is going to be ultimately is 0x negative 8x to the third, negative 28. So that's going to be a negative 40x squared, because it's 12 minus 28. The x's are going to be a positive 48x, and the number is going to be 36 minus 36, which is 0. So this is my resultant polynomial. Okay, I usually do all of that work like on a separate sheet of paper or somewhere on the side, someplace kind of like out of the way. But anyways, this is my resultant polynomial. I'm pretty sure I'm right. It's all good until algebra gets involved. All right, so here we go. So this is negative 2 x to the third x squared 0 to 2 . in mind that answer shouldn't be negative. Let me see if I can round up my answer key here real quick, because again, I'm positive that I made a mistake on the algebra. If I did make a mistake, I did everything right. But let me just take a quick glance. Okay. I'm just going to assume that my answer key is correct here, and I have this as a positive 8x to the third. I can check the math later, but I have it on my answer key as a positive 8x to the third. Everything else is in business, and I'm assuming that's right because I don't think I'm going to come up with a negative answer right there. Again, check the math on your own. Again, it's all good and fine and dandy until algebra gets involved. So let's try this one more time. X to the fourth, x to the third, and then 4x squared, from 0 to 2 with pi. Okay, let's try this again. 2x to the fourth. Yeah, that looks a lot better. Okay. So all of these are around the line y is equal to 4. So let's just see what type of boundary, what's the easiest way to integrate, and then we'll evaluate the line about y is equal to 4 when necessary. All right, so here we have a y is equal to x, a y is equal to 3, and an x is equal to 0. All right, so it seems, now again, you could do it a bunch of different ways, but it seems like this would probably be the easiest way to integrate. Otherwise, you're going to be taking this top line minus this bottom line, and it's always going to be a big R squared minus a little r squared, no matter how you shake it. All right, so this is kind of what I'm avoiding is having two separate equations, but rather one equation that we kind of have to worry about. And so what we have here is we have the equation x is equal to y, and we're integrating in all of these from 0 to 3 in this situation, and then we can rotate it however we want. All right, so here we go about a y is equal to 4. All right, so the way that I have me integrating is a dy. So this is going to be the shell method about a y is equal to 4. So this is going to be the shell method about a y is equal to 4. So here we go. So the volume in this situation is going to be 2 pi from 0 to 3. And this is going to be 4 minus y. The equation I have is y dy. Okay, so this is 4y minus y squared from 0 to 3. So this is 2y squared minus 1/3 y to the third. 0 to 3 pi straight up 9. So I have that one coming out to be 18 pi. This next one, I think, gets some LNs and stuff like that involved. So we'll see. So I have no idea what this equation looks like, so I'm going to use my calculator to kind of help me out. So I have 3 divided by 1 plus x. I'm assuming it's a swoopy swoop kind of graph. Yeah, okay. So so we have a picture, and this is at -1 is this vertical asymptote, something like that. So this is a boundary, y is equal to 0 is a boundary, x is equal to 0 is a boundary, and x is equal to 3 is a boundary, right here. So the easiest way to integrate in this situation is up and down, so we have the same top and same bottom, no matter where you look on that. So this is going to be the disk method. And so the easiest way to do this is a dx method, and we are going from what, 0 to 3. However, the axis of rotation is still 4. Okay, but at least it's still a dx, so I don't have to do the disk method. So this is going to be the disk method. I don't have to do the shell method. So here we go. Volume is going to be equal to pi from 0 to 3 of the big radius, which is 1 plus x it's 3, 1 plus x to the -1 squared dx. Okay. So what's going to happen is this is going to turn into a 9, and I'm going to factor it out right here. So this is going to be 9 pi 0 to 3 of 1 plus x to the -2 dx. Okay, I probably don't have to, but I'm going to. I'm going to use u substitution in this situation. So u is going to be equal to 1 plus x, and thus du is going to be equal to 1 dx. So that's fine. That totally exists. Nothing is crazy. And then so that's totally fine. And then I have a 3 that is going to turn into, again, I'm putting this in u, but it's going to turn into a 4, and a 0 that's going to turn into a 1. Okay, so this is going to be a u -1. Oh no, I know what I did wrong. I started to set this up completely incorrect. I'm sorry. You got to go back all the way to square one. Like, I didn't take the new axes into consideration. I did not take the new axes into consideration. I am sorry. So here we go. So the equation is 3 of 1 plus x. And then we have to subtract off that new axis of rotation. So this makes stuff way more difficult. Okay, this makes stuff way, way, way more difficult. Um, I'll kind of give you the cliff notes here. Again, I'm just stealing from my answer key here. I did the math on kind of simplifying this out to what this kind of looks like. And I think this kind of looks like this. Pi 0 to 3 of -9, 1 plus x to the -2, plus 24, 1 plus x to the -1. Okay, again, if you want to do the math, that's up to you. I'm just going to kind of steal this answer just for time's sake, in essence. So here I am going to use substitution, and it's still going to be 1 plus x. This is totally cool. Separate these integrations. Yeah, I did. So I separated these integrations. So this is -9 pi 0 to 3 of 1 plus x to the -2. And then this would be 24 pi 0 to 3 of 1 plus x to the -1 dx. So I separated the integrations. So the first one, u is 1 plus x, du is equal to 1 dx. That's totally fine. 0 is as 3 is manipulated to 4. 0 is manipulated to 1. So -9 pi from 1 to 4 of u to the -2 du plus 24. Again, this is the same difference. I don't know if I am absolutely on the wrong base here, but this is what I kind of felt comfortable with. So they're both 1 plus x's. Okay, so these integrate a little bit differently. This goes to -1, so this would be a +9 pi in the world from 1 to 4, and this turns into ln in the world of 1 to 4. So this is going to be 9 pi of 1/4 minus 1. And then this is 24 pi of ln of 4 minus the ln of 1, which is 0. So this is 9 times what? -3/4. And then this is 2 ln of 2. So this is going to be 48 pi ln of 2. And then I don't know if it gets much better than that. I'm going to kind of like call a fight right there. You could factor out a pi if you really need to. Yeah, but that's kind of where it stops. No, great. There's more. Okay. Hopefully they get a little bit easier. That one's a stupid question. I don't know why it's there. Whatever. Yeah, looks like they get a little bit easier. All right, so here we go. Find the volumes generated around an x is equal to 5, okay? So we have y is equal to x, y is equal to 0, y is equal to 4, and x is equal to 5. Oh, stupid people. All right, so I'm assuming that they are not including this area in their calculations. Let's not include that area. And instead, we are talking about purely this area that I have this. And so the easiest way is probably to integrate this way right here. And this is x is equal to 5, and this is also the axis of rotation. All right, so this is set up to go dy style, and so this is going to be the disk method, big radius minus little radius, with the manipulation of a -5 on this stuff. Um, 0 to 4. 0, that's 4. 0 to 4 of the big radius. Again, we're going from the orange dash, and that will be the slant line. And so the slant line is x is equal to y, so y minus 5 squared minus, the little radius is x is equal to 5, so technically that's 5 minus 5 squared, so we don't have to worry about that aspect of the problem right there. All right, so this is what, y squared minus 10y plus 25. Again, around x is equal to 5, I got to keep that in mind. Okay, x is equal to y squared, and x is equal to 4. All right, so the best way to integrate this is side to side. It's almost mandatory, so that's a dy style. And this is being around x is equal to 5, which is a vertical, so that's also, that plays into it. However, I have to remember this new axis on both the big and the little axes, or excuse me, the big and the little radius from that axis. All right, so from that axis, you'll note that the big radius is the parabola and the little radius is the line. So the volume in this situation is disk method, so it's going to be pi from, this is what, -2? This is +2. Again, set these things equal to each other. 4 is equal to y squared plus or minus 2. So -2 to 2 of the big radius, which is the parabola, so that's the y squared minus the new axis, which is 5, right? X is equal to 5, yeah. So that's the big radius squared minus the little radius, which is 4, again, minus 5 squared. Again, it doesn't matter if you get a negative answer because it's getting squared anyways. All right, this is y to the 4th minus, minus 10 y squared plus 25, and this is going to be minus 1, so this is going to be a plus 24. It should be the same thing, but negative. Here's 832 joules. 832. Okay. So let's revolve this around the x-axis. So the easiest way to probably integrate this is x is equal to 3, so this goes up to 9. I'm guessing that this is the easiest way right here, and so that is going to be x is equal to the square root of y. That's probably the easiest way to integrate. And so let's go about the x-axis. So if I go about the x-axis, this would be a dy style. And so thus the x-axis answer would be by doing the shell method. Right, and I am absolutely going to, I'm going to try to cheat as much as I can and use my calculator to come up with decimal answers. I don't want to really drag this problem out longer than what it really has to be. All right, so here we go. We got to make sure we set it up correct, though. Okay, so doing the shell method, this volume is going to be equal to 2 pi 0 to 9 of y, and the equation y square root of y dy. Okay, and as I said, I'm going to use my calculator here to absolutely do this thing because I really don't care anymore. That's kind of where I'm standing. And so this is going to be with respect, I'm going to call it x from 0 to 9. And then I got to multiply this by 2 pi. Okay. If you want to see the actual algebra of it, I believe I did it on the answer key, so take a look at it there. But right now, I'm just kind of, this is how I would really do it if it were up to me. All right, so that is that. Now the other way, the other question is, okay, about the y-axis. And so that, again, this is set up in the dy form. And so if it's about the y-axis, this would be the shell method, or excuse me, the disk method, and it goes to the axes. So that's pretty decent. This is set up the way that I want. So this is the disk method. So this is going to be pi integral from, again, 0 to 9 of the radius, which is the square root of y squared dy. pi r squared. Okay, there's no two radii. It is what it is. All right, so that's just y, square root of y squared is just y. So this is going to be the integral of y, or aka x, with respect to x, from 0 to 9. And then I have to multiply this by pi. All right, now we get a little froggy and move that axis of rotation to x is equal to 3. So x is equal to 3 is over here. Okay, x is equal to 3. So again, that is a vertical axis. That's awesome. So we are going to do the disk method, but the big radius is now going to be 0, and the little radius is going to be the square root. Okay, so this is now the big radius right there, which is technically x is equal to 0. All right, so again, this is still vertical, so this is dy, which is what we want, so this is okay. So this is going to be pi integral from 0 to 9 of the big radius, which is 0, minus the new axes, which is 3 squared, minus the square root of y squared dy. So I'm going to do one cleanup step so I don't enter a bunch of bull crap into my calculator. There, much more clean. All right, so here we go. Math 9, we're integrating 9 minus y with respect to y from 0 to 9. Get that times pi. Comes out to be 127. Oh, shoot. No. Same freaking answer. It's because I didn't move the axes of that second part right there. All right, so again, this would be, I'll just type it in. Just type it in. So this is going to be -3 squared minus square root of y, I call it x, minus 3 squared. Yeah, we're good. With respect to x from 0 to 9. Times pi. And this is 212,057.5. Okay, so put these in order from least to greatest. Least to greatest. So least, second least, greatest. We'll go y 3x. Thought that was it. Okay, let R be the region bounded by the graphs of y is equal to 3x. Y is equal to 4x squared. Let's take a look here. Okay, yeah, so it does technically, I'll make it kind of extreme here. From the world from 0 to 3/4, where does that intersection occur? Okay, it does intersect at an x coordinate of 3/4. So this is the situation. What is the volume? And this, what I noticed is they have a singular pi out here, so this is most likely going to be the disk method that they're implying. No guarantees, but we'll see. So the disk method is kind of what they're looking for. And so this is about the line y is equal to 4. So y is equal to 4 is way up there. So the big radius is the blue, little radius is the red, and you'll see exactly what I mean by how people write this differently. Okay, so this is going to be the volume of this situation is going to be pi integral of 0 to 3/4 of the big radius, which is the blue radius, which is the parabola, so that's the 4x squared, minus the new axes of rotation 4 squared, minus the little radius, which is the 3x minus the new radius squared, dx. So, again, how people are going to write this almost all the time is they write it backwards. So you'll see it as like 4 minus 4x squared, and you'll see 4 minus 3x. Again, it doesn't make any difference technically, but again, this is how almost everybody shows it. And so, what do you know? It's right here. All right, so what do you know? Okay, use the shell method to find volumes of the line. About the line, x is equal to 4. That's fine. So let's use this to our advantage. 2x minus x squared. Okay, so we have a teeny tiny parabola here. All right. And y is equal to 4. Now they very specifically say they want the shell method. They want the shell method. And so x is equal to 4 is fortuitous for us because 4 is over here somewhere. So where's the top of this mountain here? Nope, sorry. We are, don't care. I do need to know where this stops though. This is 0 and positive 2. Okay, so we are integrating this way. This is the easiest way, obviously, and so we would like to do it dx. However, they want it around a vertical line, so that's fine. We'll just change. Okay, we'll be fine. All right, so here we go. Our volume disk method from 0 to 2 is our area. And this is going to be x as your 4 minus x, because as it goes from 0 to 2, I need that to remain positive. And then our equation is 2x minus x squared. video is getting pretty long. Because it has a simple answer doesn't mean it was a simple problem. Okay, again, they want the shell method, so we're going to go top minus bottom from 0 to 2 around x is equal to 4. Okay, so here we go. Top is the negative parabola. Bottom is the happy parabola. So this is, oh man. Finally done. Hooray. All right. So hopefully you now know how to manipulate axes of rotation.